Okay, section 1.3 is going to be solving multi-step equations with fractions. So we've mentioned through all the unit 0 stuff that these things really build on each other day to day or section to section. So we've done solving multi-step equations. We've actually seen some of them with fractions already, but we're really going to focus today on clearing the fractions out of our equation. We mentioned before you don't really have to do that necessarily first. You can try and find common denominators and add things and get rid of the fractions at the end, but usually it's going to be most helpful if we try and get rid of the fractions in our problems at the beginning. That's just going to make all the solving much quicker. So just looking at this example right here, we have negative 3x, or negative 3 halves x plus 3/4 equals negative 4/3 x plus 17 over 12. So we have 4 terms. Each has a different denominator. The bottoms are different, so we can't really add any of these things together easily. So we could try and find a common, well, we will find a common denominator. We could try and put them all over that denominator and then go. I think you'll see here, though, what's going to be easiest is to find that common denominator and use it to eliminate the fractions. So if I just kind of think of this particular problem, right here. Right, so I have 4 terms, and the denominators, right, for each of the 4 terms are different. One of the terms has a 2, then a 4, then a 3, then a 12 on the bottom. So I can't really add or subtract these things together with that situation. So what I'm going to do is actually come over here. It's already been done for us, but we'll kind of look at it together. If I think of those and I'm trying to find what's the lowest common number that they all have in common, right, I'm going to list the multiples for each of those numbers, right? So 2, if I count by 2s, 2, 4, 6, 8, 10, 12, and so on. 4s, 4, 8, 12, 16, 20, 24, 3, 6, 9, 12. You can see what we're doing there. What I want to do is find the least common denominator. So I'm going to look at the multiples of all the denominators, and then we're going to find what's the lowest number they all share. All right, so usually the best way to do it is start with the biggest one, because it's going to be at least as big as the biggest one, right? So right here, when I look, the first multiple of 12 is 12, and when I come through the other numbers, I see they are all multiples of 12. So 12 would be the lowest common, or least, whichever way you prefer, lowest or least common denominator. And actually for this method, or for any of these methods, it doesn't really have to be the least common, right? I could also choose 24. Right? 24 is also a multiple of all those numbers, and if I use that, I'll end up with slightly different numbers, bigger numbers, but in the end it'll all reduce down to the same thing. So what we're going to do with these problems is find the lowest common denominator for the terms that we're considering, and then I'm going to multiply both sides by that number. So I think rather than do that example like that, we're going to go ahead and do it here. So if I find my lowest common denominator for problem A, negative 13 over 4 minus x equals 1/2 x minus 1. So remember, if there's nothing listed as a fraction, right, that means it's really over 1. So here my denominators are 4, 1, 2, and 1. So if I want to identify, and we're only going to do this for the first problem, like this explicitly, right, my denominators are 4, 1, 2, and then 1 again, so I don't need to write that again. And what are the multiples of those numbers, right? So 2, 4, 6, 8, 1, 2, 3, 4, 4, 8, 12, 16. So if I think of what's the lowest number they all share, right, 4, right, they all share 4. So what I'm going to do, and it's probably, maybe it was easy to see at the beginning, but I want to at least show kind of the process if you'd like to use it. So what we're going to do on each of these to solve, I just rewrote our problem, is we are going to take the lowest common denominator and we're going to multiply both sides. Right? Remember our rules of equality, our properties of equality. Whatever I do to one side, I can do to the other side, and it'll keep my equations equal. By multiplying, we'll see here, by multiplying by this lowest common denominator, right, I'm going to distribute this through both of these. What ends up happening, I'm just going to kind of do this one really long-handed here, so we can see exactly what happens. Oops, I forgot the most important part. I distributed my 4, so 4 times negative 13 over 4 minus 4 times 1x is 4x equals 4 times 1 over 2 minus 4 times 1. So I distributed my 4 on both sides. And if I multiply by the lowest common denominator or any common denominator that they have, it should eliminate all the fractions. And so we practiced this with our elimination last week. 4 over 4 is a 1, right? 4 over 2 is a 2. So by using kind of the reduction first, I'm able to keep the numbers small, right? So negative 13 minus 4x equals 2 times 1 is 2, x minus 4. So now I'm in a situation where I can solve using 2 steps. So I'm actually going to kind of just work another one from the beginning. So that one, obviously we didn't solve it for x all the way, but for the sake of space, I'm going to go ahead and just do a new one. We got plenty of examples here. So I'm going to try and determine our lowest common, denominator. All right, so my denominators are 12, 2, and 1, and 3. So the lowest common denominator, what's the smallest number they all go into? They all go into 12. So I'm going to go ahead and I'm going to take both sides and I'm going to multiply by 12. And when I do that, all right, if I distribute the 12 all the way through, I'll see that I get, again, we'll start to cut some of these longer steps out once we get the hang of things, right? I have 13 times 12 over 12 minus 1 times 12 over 2x equals negative 12x over 1 plus 12 times 7 over 3. So I multiplied it all the way through, and I can probably start to eliminate my fractions now. 12 over 12 is 1. 12 over 2 is 6. 12 over 1, I'll do the same thing, is 12. And 12 over 3 is 4. So I've reduced the numbers, and that should eliminate all my fractions. So 13 times 1 is 13 minus 6x equals negative 12x plus 4 times 7 is 28. I don't have a ton of room on these, but I'll try and squeeze it in here, right? So what I would like to try and do, actually, go the other way. So now we need to get all the x's on the same side. So we'll go ahead and do something like that. And we talked about trying to keep the x coefficient positive. So I could add 6 to both sides, but that's going to still leave me with a negative. If I add 12 to that side and do the same over there, right, I would have 6x. Those went away, equals 28. And then if I, oops, a little sloppy here. Negative 6 plus 12 is positive 6. Then if I subtract away the 13, and I end up with 6x equals 28 minus 13 is 15. And then divide both sides by 6. X equals 15 divided by 6. And we just practiced reducing fractions not too long ago. If I divide both of these by 3 to reduce my fraction, 3 goes into 15 5 times and 3 goes into 6 twice. So you can see these are pretty long problems. These are some of the longer problems that we'll actually encounter in Math 1, at least this first semester. So it has a little bit of everything. It's got fractions, it's got distributive property, it's got reducing fractions, and then it has solving with 2 steps, and there's usually a lot of negatives involved. So these can be a little bit lengthy. And maybe for the sake of space, we'll kind of do another one here. So if I think of this problem right here, 4/3 x plus 1 equals 5/3 x minus x, right? My lowest common denominator is 3. Right? So 1 would be 1 over 1 minus x over 1. So my denominators are 3 and 1. So I would need to have my lowest common denominator of 3. So this one I'm going to actually do the same thing actually. So if I take and multiply each side by that lowest common denominator, right, we would multiply it through. And this time I'm going to maybe try to not write so much and see if we can kind of do a little bit of this in our head just to save a little bit of space, and it's good to push you guys a little bit. So here I'm going to multiply the first one through, right? 3 times 4 would be 12, and 12 over 3 would be 4. And I still have my x. Or I could think of 3 over 3 is 1, right? These would go away, right? And I'd be left with just the 4x. I gotta be careful though, because the 3 still applies to the other one, but just giving you a visual. Right, so if I multiply this 3 through, right, 3 times 4 over 3 got rid of the bottom, plus 3 times 1 is 3. And over here, same thing. The 3's would cancel in the first term, and I'd be left with 5x minus 3 times x. So I found the lowest common denominator, and I distributed. And actually, in this one, I can see over here, I have 2 terms with the same variable combination, or just a single variable in this case, so I can actually combine like terms. 5x minus 3x is 2x equals 4x plus 3. And then to get all the terms on the same side, we said we typically want to make the coefficient positive, but in this case, the faster way would be to subtract the 4x. So 2x minus 4x is negative 2x equals 3. And then divide both sides by negative 2. X equals 3 over negative 2. So now I'm going to kind of maybe even try to, so the first kind of example up here, we really focused on finding the lowest common denominator and multiplying that through. We didn't even solve the problem, just showing you how to do the first part of it. The second problem here, problem B, we found the lowest common denominator and then multiplied it through using distribution and did solve it, and you can see how long that was. The third one, we eliminated some of the fractions in our head first, and actually we'll look at a slightly different way here too. For problem E, the lowest common denominator. Again, if there's nothing on the bottom, that means it's over 1. So our denominators are 6, 1, 1, and 2. So the lowest common denominator, the smallest thing they would all go into, is 6. So if I think about what happens, if I look over here when I distributed, like in problem A, right, if I think about how I distributed the 4 with this term and then the 4 went to this term, I ended up just really multiplying every single term by 4. That's the result of distribution. So something kids in the past have kind of used as a starting point with these once they get comfortable with them. I found the lowest common denominator, so now I'm just going to multiply every single term by that lowest common denominator, because that's really the result of distribution, right? It's going to end up with every single term, and by doing that, it helped them eliminate things a little bit easier because we could do it more visually. So 6 over 6 is 1, 6 over 1 is 6, 6 over 1 is 6, and 6 over 2 is 3. So by multiplying each one, I'm even able to kind of cut another step out of writing the solution, right? And so I end up with negative 31 minus 6x equals 6 times 3 is 18x plus 3 times 3 is 9. And now I'm in a pretty good spot to try and solve this, right? Add the 6x to both sides. Put this one away. And then I need to get rid of this 9 over here. And then divide away the 24. So I'm left with, I'm just going to write it this way for space, x equals negative 40 over 24. And reducing those fractions like we did before, they're both even numbers. So I'm going to think if they are divisible by 4, right? They're both divisible by 4, but then it'd still be even. So I'm going to try another multiple of 2 by 8. So if I divide each of those by 8, 8 goes into 40 5 times, and 8 goes into 24 3 times. And so x would be equal to negative 5 over 3. And I'm going to do one more using that same kind of method. Let's just do g. They're all about the same level of difficulty. So if I do g, and I think about those denominators, the lowest common denominator for problem G here, the lowest common denominator, 6, 2, 1, and 3 is 6. So I'm going to do what we practiced on the last one, and I'm going to multiply every single term by 6. All right, because if I put parentheses around each whole side and multiplied it by 6 and distributed them through, really that's what I end up with. When I end up writing it this way, it makes it a little bit easier to see the reduction of the fractions. So 6 over 6 is a 1, 6 over 2 is 3, clear. 6 over 1 stays a 6, and 6 over 3 is a 2. So when I multiply those numbers through, right, 1 times negative 13 is negative 13. Watch my sign, there's a minus sign in there, right? 3 times x is 3x. 6 times x is 6x. Another minus sign, 2 times 8 is 16. So by multiplying by the lowest common denominator to both sides, I'm able to eliminate all those fractions, and now I'm just solving two-step equations. So add 3x. Right, that'll make that go away. And remember, I want to try and keep these positive. So if I subtracted 6, I just have a big old negative. I'd rather have positives. So there we go. Getting rid of the x's on the left. And now let's get rid of the constants on the right. So make those cancel out. 16 minus 13 is 3. Equals 9x, and we're going to divide both sides by 9. 9 over 9 is 1, so that goes away, and I end up with x equals 3 over 9. I can reduce that fraction to 1/3. So there's a few more examples on there you can try on your own. I don't want to make this terribly long, but this is one of the longer things we need to do in Math 1, and if we can do these problems, we'll be really successful with all the stuff that we've got coming our way this semester. So just reminding ourselves of the process. When I have two-step equations, right? So typically when I have, especially when I have x's on both sides of the equal sign, or whatever my variable is on both sides of the equal sign, it's going to be really helpful if I eliminate the fractions first. So we're going to find the lowest common denominator, multiply each term by the lowest common denominator, and that'll eliminate fractions. And then we're just solving our two-step equations by getting all the x's on one side and the constants on the other side, and solving for our variable through our properties of equality.